All right, in this lesson, we're going to be using permutations and combinations in probability problems. So when solving word problems, solving the word problem specifically for this assignment, you're going to be entering your answers as percentages rounded to the thousands place. Before we actually go over some examples, it's important to understand what a binomial experiment is. Binomial experiment is an experiment where each trial has only two outcomes, thus the name binomial, and there are a fixed number of trials. Each one of the trials is independent, and the probability for each one of those trials is constant. It's the same for each trial. Here's the formula that you can use for binomial probabilities. You can likewise use a similar expression that is used in tandem with the Pascal's triangle. All right. So you can use the binomial theorem that was previously discussed and use the expression s plus n to the nth power, where s is the number of successes, n is the number of failures, and n is the number that you're choosing. So you've got a politician is about to give a campaign speech, and it's holding a stack of 8 cue cards, of which the first 3 are the most important. Just before the speech, he drops all the cards and picks them up in a random order. What's the probability that the cards number 1, number 2, and number 3 are still in order on the top of the stack? All right, so there are 8 cue cards, and the first 3 are the most important. So we're looking at the number of permutations. You have 8 to choose from, and then of those 8, you're going to choose 3. So that tells us that there are 336 permutations, of which 1 is the order that we want. So we divide 1 by the number of permutations, 336, to get a probability of 0.298%. All right, for the next example, it says one day 9 babies are born at a hospital. Assuming each baby has an equal chance of being a boy or a girl, what is the probability that exactly 7 of the 9 babies are girls? All right, so there are 7 of the 9 babies. This is a binomial experiment. And so we are going to use the formula that was on the previous slide. N is 9. There's 9 babies to choose from. X is going to be 7 because we're choosing 7 of those 9 babies. Once we plug in P is the probability of having a girl. So since the probability of having a girl is 50%, we enter 0.5 for P. And then the probability of 1 minus P is just going to be 1 minus 0.5, which is still 0.5. So after we do the calculations for the coefficient, we get 36. And then 0.5 to the 7th, 0.5 to the 2nd power, or a probability of 7.031%. You could have also gotten that same term, that 36.5 to the 7.5 to the 2nd, by using Pascal's triangle. And lastly, there are 16 songs on your playlist. 10 of them are countries, 6 are pop, with random shuffling and no repetition. You listen to 9 songs. What is the probability that you listened to exactly 5 country songs? All right, so we first start with the number of combinations of choosing 5 songs. choosing 9 songs. So we have 16 songs total to choose from. And we're going to choose 9 of those songs. So that's going to be our denominator. That's the number of possible outcomes. And then the numerator, we're trying to determine the probability of getting 5 country songs. 5 country songs, so that would mean 5 country songs, since there's a total of 9 songs that we're choosing, 5 country songs and 4 pop songs. So we need to find out the number of combinations for each one of those. So our first, we're going to choose 5 country songs, and we have 10 country songs to choose from. And that would leave us with 4 pop songs, and we have 6 pop songs to choose from. Calculate all those combinations, multiply the factors in the numerator, divide them by the number of combinations in the denominator, and we get 33.042%.